let's go and write that down. We said outside equals 2 times the inside in parentheses. You're going to have to substitute in what you know, right? Hey, lie down. What is on the outside? Which one? What? 34, okay, in English. And then 2 parentheses, what is on the inside here? 3x minus 1. Fill it in, please. Okay. You got to set it up, substitute. If you need to get water, you can. Then, like we did yesterday, you want to distribute that 2, right? So what's 2 times 3x? Okay, 6x. 2 times negative 1. 2 times negative 1? Negative 2. Okay. Bring down 34. Can you solve a 2-step equation from here? So the x is on the right. All right. What do I get rid of first on the right? The loner is the minus 2. Okay. How do I get rid of a minus 2? Opposite is plus 2. So plus 2, plus 2. 34 plus 2 is 36. Bring down equals 6x. And then last step, when we have a coefficient, we divide, right? Divide by 6 on both sides. Okay, so 36 over 6 does give me 6. Okay, now this is not a trick. We truly do need to do some notes. They're short. We're going to get them done fast. So let's get this done. Okay, 4 tricks. 4 candy for me. You have time. One day. All right, here we go. Yes. Yeah. Here we go. Circumcenter, incenter, centroid, and orthocenter. These are the 4 centers of a triangle. Okay. Now, if you look at them, they kind of look like they might all be the same. Okay. However, there are 4 different ways to get 4 different centers of a triangle. Okay. Now, the first one for circumcenter, go ahead and write this down. To get a circumcenter, you find it by making perpendicular bisectors. Write that down, perpendicular bisectors. In the back. Now, what do I mean by perpendicular bisectors? Do you see this segment MZ? Okay. Is it perpendicular? Do you see this little right angle symbol? Okay. That's what I mean by perpendicular. And then bisector cuts it in half, and you're going to see those tick marks. Okay. Hey. So for the tick marks right here, I'm going to just emphasize it. That is how I know it's a bisector. Those are the literal things you're going to look for to find a perpendicular bisector. And if you see 3 of those, that center is called a circumcenter. Okay? So let's fill out the bottom here. The circumcenter is equidistant from each what? Each vertex of the triangle. So here's something we know. When you see that you have a circumcenter, if you drew lines straight to each corner, each vertex, all those would be the same distance. So let's go ahead and mark that. Let's put 4 tick marks on each of these segments. So everybody do this with me. AM, put 4 tick marks. Hold on. BM, put 4 tick marks. CM, put 4 tick marks. From that circumcenter to each vertex, is equidistant, okay? At the bottom, write this down. AM equals BM equals CM, okay? We are 1/4 of the way done with the notes. How does it feel? Feels good. Okay, you want it to be longer or what? Okay, well then don't roll your eyes at me. What the heck? All right, in center, ready? In center is created by angle bisectors. Hey, write this down. Angle bisectors. Hopefully you know bisecting is cutting in half. So an angle bisector is when the angles are cut in half. Now look at each corner. Do you see how they have little matching arcs on each corner? That means they've been cut in half. They match the halves. So I'm going to put a little arc here to emphasize this. If you see those two angles cut, can you wait? If it's possible to wait till after this, just because it's brand new stuff. Angle bisectors, cutting those angles in half. That if you have 3 of them, you're going to get what's called the in center. Okay. Now at the bottom, this is very important. Okay. The in center is equal distance from each side. Okay. So see, my in center is M to each side. So MZ, MX, and MY, each of those distances are going to be the same. So let's go ahead and mark it with a tick mark. Everybody do this. Okay. We're going to put XM, put a tick mark, YM, put a tick mark, ZM, put a tick mark. And at the very bottom, we're going to write XM equals YM equals ZM. If you see equal distance to each side, that is an in center as well, okay? We're halfway done with the notes. Not too long, right? Nice and short for our short early release day. Next one is called a centroid. Go ahead and write the word medians. If you have 3 medians, that's going to create a centroid. But underneath the word medians, you're going to write that it goes from the vertex to the midpoint. To make a median, you connect a vertex corner to a midpoint. In my picture, does everyone see? A is a vertex, and it connects all the way over here to Y. How do I know Y is a midpoint? What? I'm glad you asked. Because we got tick marks. That ensures it's for sure a midpoint because the 2 halves are equal. Hey, you understand? Start doing that. Do that, not that. All right, so that's median, vertex to midpoint. If you got 3 of those medians, it makes a centroid, okay? And let's fill out the bottom. This is kind of what we already just said. The centroid is created by a vertex connected to a midpoint. So again, here's what you're looking for. Vertex connected to the midpoint. And you've got to see these tick marks next to the midpoint. Cool. We're 3/4 of the way done. Just one little section left. Almost done. Last one. Orthocenter is created by altitude. Let's write that down. When you hear the word altitude, what do you think of? Height. Okay, like a high altitude. So the height of each triangle is the altitude, and it's from the vertex to a right angle. So look, check this out. We got a vertex, and it goes all the way to make a right angle. If you see lines that are vertex to right angle, vertex to right angle, vertex to right angle, that center is called an orthocenter. It's created by a vertex connected to the opposite side so that it is perpendicular, makes a right angle. Make sure you have that down. That's it for the informational side of the notes. You can flip it over. I'm going to show you some examples and we'll be done. I'll do it with you so you don't have to suffer. It won't be so sad, all right? And you know what? If y'all are good, maybe I'll give you a spooky stamp. Y'all like stamps? No? Are you too old for stamps? Is that elementary school stuff? Well, anyways, headphones. Now, on the back, yeah, you, right here. Number 7. I know it doesn't start with number 1 because we're being kind of tricky today on Halloween, right? That's why we have phones in our hand, apparently. All right, thank you so much. Number 7. What is happening on number 7? So this line is from the vertex to a what? What is this? If these tick marks are here. Midpoint. Is everyone seeing this? In the back. Okay. Vertex to midpoint. What's that called when it's a vertex to a midpoint? The lines are called medians, and it does make a centroid. Do you see how to identify this? You're looking for a vertex to midpoint. 3 ways. That's your centroid. Okay. Okay, number 8. The only thing I have labeled on here are these arms. And it looks like they're cut in half. They're equal. So when you cut an angle in half, it's called an angle bisector, right? So on number 8, these are all angle bisectors. What do angle bisectors make? So I look at my notes. That's my second column at the top. That's called an incenter. Incenter. So far, so good. Number 9. What are these lines? They start at a vertex and then they make a right angle. From a vertex to a right angle. Again, I look at my notes. Which one did I say is vertex to right angle? That last one, right? Those are called altitudes, vertex to right angle. So altitudes make a orthocenter. Okay, number 10. On number 10, I see that these little lines have a right angle, they're perpendicular, and since these tick marks are here, that's a midpoint, it cuts it in half. We call that a bisector. So that's a perpendicular bisector. Again, I see which one matches on my notes. Looks like the first one. Those are perpendicular bisectors. So what is that called? Circumcenter. Now, I just showed you 4 examples. Those are the 4 different ones. So it's pretty much the same, but there are 2 tricky ones, okay? 12 and 13 are tricky. I'm going to circle those. 12 and 13, kind of tricky. I'm going to show you, okay? But y'all tell me, what do you think 11 is? Okay, these are medians. From a vertex to a midpoint, cut in half. Those are medians. That makes a centroid. All right? Now, number 12. Number 12, I'm going to tell you, is already not a circumcenter necessarily, okay? I know it kind of looks like it because there's a right angle there, but we don't know that these are midpoints, right? Like there's no tick marks here. So look, on number 12, okay? On number 12, the only thing I see is that it goes from the center to the side and they're equidistant to each side. Equidistant to each side. If you look at the bottom bubbles, that's the second one, equidistant to each side. And in our picture, we labeled that with tick marks, right? So 12, equidistant to each side, is an in-center. "13, a little different. It's from the center to each vertex, and each of those is equal. Okay, well, which one is equidistant to each vertex? Look at the bottom bubbles. That first one says equidistant from each vertex. That is a circumcenter. Bless you. Circumcenter. Okay, what about this last one? What are those lines on the last one? Vertex to right angle. So they're not angled bisectors, or they have little arcs. What else? Okay, so those are altitudes because it goes from a vertex to a right angle, vertex to a right angle. So those are altitudes. That makes an orthocenter. Orthocenter. Now, the assignment for tomorrow is just a bunch of that matching. And I'll give it to you now. You can already get started on it. I know it's a short class, so we're almost done. Give it to you early, but you do have class time tomorrow. You also have class time to make up stuff that you need to, okay? And I'll come around if you want to stand. Give you a stand, all right?